Welcome to ARVN, Amateur Radio Video News. The program you're about to see is free to watch, courtesy of YouTube. Thanks, YouTube. But it wasn't free to make. ARVN's got a lot of money invested in video equipment like this sweet camera and that editing system back there. And it takes a lot of time to shoot and edit a program like this. So I'm asking you to make a voluntary payment, contribution, whatever you want to call it. Just stop by our website, arvn.tv, and you'll see a link to make that payment, whatever you think the program is worth to you. I guess you could say that this program is brought to you by you. So thanks for watching and enjoy the show.
My name is Mark Braunstein WA4KFZ, or phonetically Whiskey Alpha 4 Kentucky Fried Zucchini. So that's how I make it easy for people. Is that a Z or a C? So I said Kentucky Fried Zucchini. And anyway, this is just an overview of D-Star, both voice and data, but this is intended as just a broad brush, high-level overview of what D-Star is, the technology, and I want to call it the promise, if you will, of things that we could do with D-Star in amateur radio. If you notice here, this says the National Capital Region D-Star Association, to which I encoded it in binary here just because we're all digital geeks here. So what is NCR D-Star? It's just a short plug. It's basically just a bunch of people, groups in especially the Northern Virginia area, although we do have one repeater that's working with us in Virginia Beach. But basically people in this area that are just interested in D-Star, promoting D-Star technology. So we don't collect dues or have elected officials or anything like that. We're just a bunch of people interested in D-Star and helping others out in D-Star technology. But we do run reflectors 025 Bravo and 025 Charlie, and we'll talk about reflectors a little bit later here. And we do have a website, the ncrdstar.org, and we're slowly adding more information. There is a wiki that people can add information up there and help educate the public as well. Okay, so let's go ahead and we'll just take a quick perusal through and understand what D-Star is here. Okay, so what does the acronym mean? It stands for the Digital Smart Technologies for Amateur Radio. It's a mouthful, I know. Obviously, they picked an acronym and then tried to figure out, how to wrap some words around it. But the neat thing about D-Star is that you are able to do simultaneously voice and data transmission, something that we really haven't had the opportunity to do in amateur radio in the past. We've either done voice or we do packet, which is just data only. Okay. Here we're actually able to do both voice and data simultaneously in our transmissions. It's also a packetized structure, which makes it easy to pull information apart and route it through computers and computer networks. But one of the real beauties of D-Star is that, as this word says, digital, everything is digital at the source. All right. Especially with voice. Your voice is digitized at the source, right at your radio, your microphone, so that the quality is not going to be degraded as it proceeds down the communications channel. And I think, how many of you use like Echolink or IRLP? Let me just show of hands. Okay. Have you ever noticed in Echolink how the audio quality tends to vary? Some sites are really good and others are abysmal, So what you'll find is that because of how signals are coming into like an Echolink network, especially if they're coming through a radio link or whatever, sometimes the audio can be rather poor. But the nice thing about D-Star is because everybody's voice is digitized right at the source, you're only passing digital data, and everybody will have consistent audio quality. The other thing is that D-Star uses less bandwidth than our current analog counterparts. There is a push in the public service sector to go to narrowband communications. They're trying to get as many users as they can in the spectrum as possible. And there's a big push now to go from 25 kilohertz channel spacing to 12.5 kilohertz down to 6.25 kilohertz. ICOM and D-Star plowed ahead and they went all the way down. They went for the gold, if you will. And D-Star occupies a bandwidth of, or has an emission bandwidth of 6.25 kilohertz channel spacing. Okay. Another unique feature with D-Star is that because of this digital architecture is that it uses call sign based routing. And this is one of the topics that Bob Renega wants to have a discussion on tomorrow, is about the whole routing technology. But that's probably one of the interesting things about ham radio today. If it's packet based, it's going to be a call sign based routing system. But if it's voice, you have to announce who you are, what you're doing. D-Star can operate standalone. You can do simplex communications. You can communicate through a repeater just like you run through an analog repeater today. And you also have, the one powerful thing is you can tie in as a D-Star repeater as a gateway, and now you can access the internet and greatly extend the reach of your D-Star network. Okay, this is not to scale, but it's representative here. But the neat thing is that D-Star only has an occupied bandwidth of 6.25 kilohertz versus analog FM. It's going to be closer to about 15 kilohertz here. So it's narrow band. In theory, you can put a D-Star repeater in between two analog repeater allocations. Now I'm going to use a little asterisk caveat smiley face on that and say, under the assumption that the two analog repeaters that you have are good enough that they can tolerate having a signal sitting in between. This diagram may seem to indicate that the universe is very carefully confined. You'll find that a lot of older repeaters, their filtering is not that great. But if you work with the organizations that are responsible for repeater coordination, and if repeaters are far enough away, it is possible to actually go ahead and do allocations and actually put D-Star repeaters in between the existing analog repeaters. Sometimes they've actually moved channel spacing a little bit further apart, for some of the analog repeaters, ask them to move things around. But in general, yes, you can do this. You can actually do that. So the one thing is that D-Star, one of its selling points by virtue of being narrowband communications was that it was intended to help relieve spectrum crowding. Okay, so like I said, you can put it in between, or if you got rid of an analog repeater, spectrally, you could actually fit two D-Star repeaters side by side in the same spectrum. All right, that's the spectral efficiency part here. Okay, D-Star started in Japan, I believe it was around early 2000 or so time frame. It started as this open protocol from the Japan Amateur Radio League, or sister to the American Radio Relay League. There is an open source document. If you just go out and do a Google search on D-Star specification, ARRL D-Star specification, whatever, you'll find the documents out there. Now I'm going to say something. When they say it's an open source design document, you'll find it is very Spartan. It is very, very open. It was really written with a lot more information on the call sign and network protocol side and very little on the radio technology side. So it's something that really needs to be fleshed out more in the amateur radio community to really put some meat to it. So it's very, very bare bones as a standard. Okay, as we said, D-Star offers both voice and data capabilities, or you can just do data only. On the 2 meter and 70 centimeter bands, we can do simultaneous voice and data. All right, so if I have a handheld radio similar to this one here, there is a data jack here on the side. I could be simultaneously sending data, whether it's GPS, whether it's keyboard to keyboard chat or whatever, while I'm simultaneously talking. Now, unique to D-Star, there is a 1.2 gigahertz only radio, it's called the ID1, that will do the standard voice and data at low speed, but it has a high speed capability and is able to send transmissions at 128 kilobits a second. So that is only at the 1.2 gigahertz frequency range that they cover that with the ID1. Okay, I only threw this in here because Bob Renega has this whole thing on Sunday where he wants to talk about the whole routing of call signs and trying to adapt things here. So I threw this in as a perfunctory introduction, if you will, to the whole call sign routing aspects to this. honestly, the only way you're ever going to learn is to get a D-Star radio and play with it. To which I was going to ask, how many here do not own a D-Star radio? Really? Okay. I thought in this like super high-tech crowd here, everybody would be like, I already got one of those.
No repeaters in my area. Yeah, I sold mine. Yeah,
Really?
Yeah, I've been told there's a ton of repeaters in my area, but they don't show up in the AWR repeater directory.
Okay. The comment was about repeaters in your area. Which area do you live in?
Eastern PA.
Eastern Pennsylvania. Okay. This is one of the things we're really trying to encourage here and with NCR D-Star and just in general. We'd like to see more repeaters in the Maryland area and further up. Seems to be a lot of them down south. We're really trying to encourage more of them to show up in the DC area, Maryland, and further out. Anyway, so we're just diverging there for a moment. In D-Star call routing, you basically have in your radio different fields that you can program here. One of them is what they call my, which is my call sign, my source call sign, and your, which is who I'm trying to get a hold of. Now I can call CQ, CQ, CQ. I can just say I'm going to talk to anybody, all right, and use that as a call sign, and that's actually the default for a radio, okay? Or I can put in a specific user's call sign. All right, so you have the capability of doing both. There are two other fields. Sometimes you'll see it referred to as RPT1 for repeater 1, repeater 2, or just R1 and R2, depending on the radio you've got. But basically, you're going to program in two settings that relate to these repeater functions here. One is the actual radio repeater, the actual radio access point that you're coming into. And the other one is going to be either another repeater module or it's going to be your connection out to the gateway. So it's basically routing information is what's contained in these two R1, R2 settings here. Okay, so I showed a couple of examples. The internet connection here, for whatever reason, is pathetic. I can't show you live, but there is this very nice little tool, especially if you're learning D-Star. It's called the D-Star calculator, or web calculator. And it's actually a very handy little tool that you can go in and just pull down menus. And when you're done, it gives you the answer. And this is what you plug into your radio. And this gives you a little network diagram here. So I used an example. I said, if I was just going to talk to my friend Jeff, N5ITU, he lives in Texas, how would I actually get a hold of him? He does have a D-Star radio. And let's say if I was sitting back closer to home, I'm a member of the old Virginia Hams, we have a D-Star repeater, the W4OVH. The B stands for the port, and there's the designations that they use in D-Star. A, and this basically came from Japan, and this has to do with how they do operation in general with radios in Japan. A was a reference to any of the 1.2 gigahertz radios. B was a reference to 440 megahertz, and C is a reference to any of the 2 meter frequencies. 1.2 gigahertz is actually more prevalent in Japan due to the topography there than it is really here because we have so many mountains and other obstructions here. That's kind of how they set that priority, if you will. So this says that if I want to talk to him and I'm close to home and I'm going through the W4OVH repeater, I'm coming into port B, which is the 440 repeater. Now, if I want to get to Jeff, he lives in Texas. So what I'm going to do is I'm going to actually tell this thing that I want to route my signal out through G, which means gateway. All right. And what's going to happen is I'm going to transmit, go through our local repeater in Manassas, and go out to the great unknown here. You notice this question mark? The neat thing about D-Star is that if Jeff has been on before, there's a trust server that manages all these connections. So it knows where Jeff was the last time. And what it's going to do is it's going to route my call to wherever Jeff was the last time. So if he was on his local repeater, it's going to put out a broadcast and it's going to show up there at his local repeater where he was the last time. Okay? So if he's there, Then all he has to do is he'll see I'm calling him, my call sign will show up as being the receive call sign, and on his radio he just pushes this button, this receive to call sign button, captures my call sign, and now we're ready to start having a conversation. Okay. So the neat thing is that this trust server architecture helps you find the stations. It lists where they were or last known. If you drive to another area, all you have to do is just key up, get into the D-Star network, the trust server gets updated and it finds you in another location. You know, so if he drove from Texas and went to visit our other friend over in Alabama, you know, or whatever, or Georgia or whatever, you know what I mean? He can just key up and he shows up in the network there. Okay. There are two methods of actually connecting repeaters together. There is the ICOM way, and there have been add-ons. Robin WA4KFZ, he's the guy who's built a lot of add-on toys, if you will, for the D-Star work, has a different method that he introduced here with something called D+. They both work. You're actually going to find, I think, by virtue of how we tend to use things here in the US, that the other mode, which is linking, which I'll talk about in a second, seems to be more prevalent. But as written and deemed by ICOM, I can actually connect these two repeaters together. Okay? So let's say if I wanted to connect myself and I want to pass myself through and actually come out and appear at the 2-meter port on the NV4 FM repeater, which is around Tyson's Corner, okay, I can actually address this and route so that actually I'm now coming out of that module there. So anybody who's on the 2-meter module in the Tyson's Corner area would now be able to talk to me here. This slash is what says I'm doing port routing. All right, this is just ICOM's designation that they use for this type of a port routing arrangement here. Okay, so basically if anybody else is on that port C repeater and I'm coming in on 440, I can talk to them. All right, same thing, they just capture my call sign, they put it in, now they can start talking back to me. Associated with this, there is also the capability of doing what they call multicasting. The NCR group, for a while, we were using, and then we've changed over to another configuration, but we still have listed as existing what they call multicasting, where you can just change this to just a default name. Like for example, we just had /NCR. And what that did was all those repeaters that I had listed earlier, we could multicast to all of them. So if I wanted to talk to everybody throughout the entire Northern Virginia area, that's from Stafford, you know, or Virginia Beach or whatever, all the way up to Arlington, I could go just put in my call sign there as /NCR, come in through my whatever, one of these local repeaters, and I could be broadcasting out over the entire area. And needless to say, you got to be really careful about that, because otherwise you're now tying up all of the D-Star repeaters in one area. So it was really intended for nets, emergency broadcast applications. It was not intended for general conversations, you know, because you're really, one user is now tying up multiple repeaters. Yes, Bob?
If one of those multiple repeaters is already in use or is already connected to somebody else, is it still, in D-Star, can multiple things be connected to one repeater at the same time? I'm probably not using the right terminology.
Yeah, I haven't actually had to run into that issue. I know there is concern, and some people have complained about things where if you do the routing in this method here, that you are actually breaking into an existing conversation. I don't know if they've changed that in the gateway routing systems or not. Okay, but that was one of the complaints basically is, you know, if I'm breaking into a repeater and there's a conversation going on here, all of a sudden I'm coming in to that, and I think sometimes it was disrupting it, especially if the other users on the other repeater were connected to something else like a reflector, okay, which we'll talk about reflectors in a minute here. So, a few limitations. So there's a lot of power within D-Star, but you have to respect this power. Okay, there is another method of actually linking or doing this call sign routing for repeaters, which is more of a traditional linking. And this is more like you would do in Echolink and IRLP type arrangements here. Robin WA4KFZ came up with some add-on software, basically. It's an application that runs on top of the existing D-Star gateway software. And he calls it D+. And he added a couple of bells and whistles. Like one of them was an echo test. So you could put in a call sign, for the repeater, like W4OVHE for echo, transmit, let go your push to talk button, and hear your audio come back. So that was like one of the features that he added with this D+ arrangement. So what he did is he just kind of followed the more traditional modes of connecting things together, similar to Echolink and IRLP. So he was just using this linking arrangement. So the L here is a reference to linking. Okay. They both work in pretty much the same way. It's just the difference between the two gateway software configurations here. One of the areas where D-Star is probably more powerful in a sense is the ability to connect to high bandwidth reflectors. So now you have something that's a little bit more akin to a conference bridge. All right. You can actually link to this high bandwidth connection point ad hoc, and now you can start talking to anybody who's hooked up to that conference bridge, if you will, have a communication, and you can pull out when you're done. And you're actually finding more groups are really going in this direction of actually just having these high bandwidth reflector sites. You just go in, you ad hoc link as you need to, and you pull out when you're done, as opposed to taking control of the other repeater. But the neat thing is everybody can then be connected together, and because you have that consistent audio quality, everybody sounds good, okay, which is the nice thing about the digital audio. Okay. And that was my perfunctory nod to call sign-based routing for D-Star. Okay, if you want to kind of get into the guts of what a D-Star radio is, okay, this is a general representation of a D-Star radio. What you have on the right is essentially just a packet type transmitter, although we just happen to use GMSK, Gaussian minimal shift keying, okay, instead of FSK. So it's really basically just a GMSK modulator and just reversing, and the other side, GMSK demodulator. All right. But the key thing that you're adding here is on the digital side here is you're taking in your microphone input, you're digitizing it through an A to D converter, and you run it into this AMBE vocoder here. And this is the key piece that's used to reduce down the bandwidth of your audio transmission here. After that, there's a channel coding that goes in. We do scrambling, all right? There's, for the headers of the information for call sign routing, there's convolutional coding that's done. So basically there's error correction being done in the transmissions that are going across here. So your voice is actually being processed and transmitted with forward error correction. And that's what gives the D-Star digital audio a sense of robustness. Okay. Just kind of turning it back around, you go back through the AMBE vocoder, you're just reversing the process, do a D to A conversion, and out comes to your speaker. So basically we're tacking on just that digitized audio, the codec audio, and just putting it out over the air, just using a GMSK modem. Okay, so if you kind of look down into the architecture here in this AMBE vocoder chip, so what you're seeing is this is the actual algorithm that does the vocoding. It's actually looking at the elements of your speech, if you will, figures out how to do the compression. But the important thing here, if you'll notice, is this forward error correction block. And this is where they're doing things like the RAID 1/2 convolutional encoding. All right. This is one of the things that is giving D-Star that higher quality of audio as the signal starts to drop down, in signal strength here. And then, like I said, after that, you're pushing it out. So the audio that's going in is actually at 2,400 bits a second. This overhead that's associated here with forward error correction is adding the equivalent of about 1200 bits per second of information. So what actually gets pushed out here is a bit rate that's at about 3600 bits a second. But D-Star transmits at 4800 bits per second over the air. The other remaining 1200 bits per second is allocated for that data. This is why you're able to do simultaneous voice and data. Okay? The data and the voice are interleaved. They're actually packets and they are interleaved. This is how you're able to do this. So one of the most common applications for that data stream is to send your GPS position. So you'll have a GPS module or a GPS receiver with a NEMA sentence or whatever sending out your location information. Or you're doing keyboard-to-keyboard communications. So it's all just basically mixed into the channel. You push out 4800 bits per second out over the air and away you go. Okay, D-Star repeaters, when you have all of the modules that are available in D-Star, they affectionately refer to it as the stack. Okay, and if you have a full stack, you have all of these modules. So all of these modules refers to a module that will handle both the low-speed data and 2-meter voice, same for 440. There's a general repeater controller that's doing all the housekeeping and providing the connection out to a gateway. But what they do is because of the high-speed data, the 128 kilobit per second data path that they run on 1.2 gigahertz, they actually have two separate modules there. So this one is doing the 128 kilobit per second data. This one here handles the voice. It actually does also handle the low-speed data in a manner similar to the other two modules, or the other two modules, okay, on the 2-meter and 440 side. But everything is routed together through this repeater controller. So this little piece down here, this repeater controller, is what allows you to come in through one module and route yourself and come out another. So you're doing cross-band repeating by virtue of control and routing through this little box here. Okay. It's interesting to go and look at the basic architecture of D-Star as it was proposed by ICOM. It's very interesting, and a lot of things fall out from how they do things in Japan. They do things a little differently than they do here. As I understand of the topography of Japan, there are a few high mountains, volcanoes, and a lot of flat land. That's one reason that 1.2 gigahertz is very popular there. You have fewer obstructions. If you look at the original diagrams they show for the D-Star architecture, they refer to a repeater as covering a certain area, and they refer to a collection of repeaters that are linked together by a 10 gigahertz backbone as a zone. Okay. Now in the US here, because of our differences in elevations, other obstructions or whatever, it's really difficult for us to actually have microwave point-to-point links actually bringing our repeaters together. So instead what we do is we tend to just bring them together through the internet connections as a gateway-enabled repeater. But the nice thing is that if you do have line-of-sight coverage between repeaters, if they're at good locations, you can maintain a backup link here through a microwave link here. Now, the 10 gigahertz radio that D-Star sells is bleeding expensive. It really is not worth the money that they charge. Most people in the US here have actually gone out and just bought low-cost, like Ubiquiti 5.8 gigahertz links. They're plenty fast enough for anything that we're ever going to do on a D-Star type network. And if they do have line of sight, they are maintaining that and using that as a backup path. Okay, so that in the event that an internet connection would go down, you could at least still keep D-Star repeaters running together as a zone. All right. So I affectionately say that if the internet goes out, that D-Star can and will keep on going. Okay.
Question?
Yes, sir.
As you mentioned, the cost.
Yeah.
If D-Star is not available in an area that one of us is living in, what would it cost to deploy that kind of a stack?
Well, if you had gotten in on a special, the question was about the cost of a D-Star stack, and actually ICOM recently was giving away D-Star stacks to groups and areas that they thought were underserved by D-Star. But a stack, you're looking at, for just a controller and one module, was about $3,500. Okay, so a full stack you're looking at. I don't know if they're giving any price breaks now at this point. It's probably on the order of about 10,000 or so. But they were charging that much just for the 10 gigahertz link, which is why people said, I don't think so. And they're going out and buying for a couple $100 a Ubiquiti 5.8 gigahertz link running at 54 megabits a second and doing their own point-to-point links, you know, and instead of paying all this money for the ICOM variant at 10 gigahertz or whatever.
What is a typical DCOM radio cost?
A typical ICOM radio?
What kind of range are we talking about?
I would say they just came out with the ID80, and I haven't seen the exact price on that. I think it's like I think this starts around like in the 279 range. Probably the most expensive, if you move up into the handheld range after that, the ICOM 92 AD is their rugged dual band handheld, you know, I mean the type you can submerge in water, has an external speaker mic that has a GPS receiver built into it. I think that's running at around $400. The mobile rig I have in my car is their ICOM 2820, which is their high-end D-Star radio. So when you buy the module with that, which has GPS capabilities, that was about $900. Okay.
Is there any facility, for example, if we've got a 2-meter rig and a computer, that we can do something, well, you know, a little lower scale with existing pieces?
I'm going to say yes and no. Let me show you what people are doing with the lower end equipment, and I'll explain some things later. But the one thing that you're seeing is that people are experimenting more with D-Star. There is stuff showing up, coming out there. And one of the things I was going to advocate in this talk here was in trying to encourage more experimentation. You know, I thought this was the right community, you know, if we're talking about people into technology, okay, this is the right community to talk about experimenting with it. So you have those that are on the user appliance side. They're going to go to the store, they're going to buy a radio, and yes, you get started with that. You know, but after that, there are people starting to finally get into the innards and actually starting to build up their own stuff. So let's go through a few more things, and we'll talk about some of the other things that people are doing now and trying to use and utilize, if you will, you know, the features within D-Star. Okay, so one of the first things that came out on the market was, what can you do if you don't have a D-Star radio? All right, this was built by Rob WA4KFZ, and he affectionately calls it the DV dongle. It is basically just a USB dongle that you hook up, take a computer headset, you get registered with the D-Star network, and now you can join the D-Star world. So this is about $200, okay? And you could be anywhere, and as long as you got a computer and you got an internet connection, you can now connect in and talk to people on the D-Star network without a radio. Okay, so this is probably your first entry prior to actually a radio mode. This is popular with people who like to travel a lot. Yes, sir?
And such a particular dongle, we can still run data tracking as well?
I'm sorry, running what?
You can still run the data tracking? You still have access to the...
You can, yes, you can send data through your computer, your keyboard, okay, but it is really, this really was intended just for, I mean, its thrust, if you will, was to put that AMB chip, the vocoder chip in there, and just push out the D-Star compatible audio and formatting it to go out over a D-Star network. All right. But this is very popular with people who like to travel. This is also popular for people who would be in an emergency setting where they have to come into an area and, or maybe they're coordinating something prior to coming into an affected area where there is still internet connectivity and they want to talk to the people who are the boots on the ground that are on the radio. Okay, so that's one of the nice things actually about this whole capability is being able to tie in and do this ad hoc arrangement here. Okay, so this has been a popular way of mixing and matching things, and this is the advantage of having the digitized audio. Okay, you can now start streaming and mixing these things together that you couldn't really do effectively in the analog world. The next thing that's become quite popular are things that they call these digital voice access points. Just like if you go to a Starbucks and there's a Wi-Fi hotspot, this is the D-Star equivalent of a hotspot. So now you can set up a gatewayed connection basically through your computer, hook up this little GMSK modem transceiver chip, which is really all this thing is. All right, and now you can walk around with one or more radios, and within the localized coverage area, existing D-Star radios can now communicate through a network. Okay. People are deploying these at home. I'm going to show you a different arrangement. I have sort of a higher power version of this actually running in my house. But this is just another commodity item, if you will, that's out there on the market. But this is showing where people are learning how to build and add on things that are running in addition to what ICOM is currently providing for this technology. What I'm running actually at home is a little bit closer to this. I went out and bought a used Yaesu FT2600 radio. It has a 9600 baud packet port on it. Okay, and that's becoming a common interface point now for a lot of people experimenting. Gives you the bandwidth you need, gives you the direct connection to the modulator and demodulator outputs. All right. So the node adapter is doing nothing more than just taking whatever digital data stream is passed through the packet port, formats it correctly in the D-Star format, pushes it out on my computer, out over the internet, and away I go. Well, the thing is now I got a 20-watt radio. Well, actually, I turned the power down to 20 watts just to keep things kind of tame, if you will. So now I can drive around for a couple of miles. I just have a J-pole antenna up in my attic, and I've got my radio in the car, and I can drive around as I'm doing my chores or going to work or whatever. And I access my hotspot here, and I also make it available to others. I publish the frequency, 145.615. You want to drive by my area? You want to come in? Go right ahead. Just connect up to my hotspot, and away you go. These are becoming very popular, or this whole concept of the hotspot is becoming very popular here in the metropolitan areas where it's becoming difficult to find good repeater locations. And this is actually one of the topics that I want to bring up in Sunday's discussion here about, are there ways that as technologists that we can actually try and do some sort of a cell-like handoff between hotspots so you can drive around areas and have a bunch of home deployed hotspots for communicating as opposed to spending all of the money and trying to get access to one supreme high location, which is becoming, like I said, very difficult now in most metropolitan areas.
Quick question.
Yes, sir.
On that last slide, is it able to do the GMSK through the analog radio somehow?
Yeah, I mean, basically, you're just picking up whatever comes out over the air, okay? It basically fits within the bandwidth of the 9600 baud, input and output, if you will, of that radio. And all that's on that thing is basically a PIC microcontroller for just doing the housekeeping and data formatting, and a GMSK modem chip.
So it's basically a D-Star GNC.
Yeah, pretty much, yeah.
And it works just fine with the normal analog.
Yeah.
Band.
Yeah. Yeah, you just you have to tweak the audio level a little bit just to kind of get it right or whatever. But honestly, I haven't found it to be that difficult to set up.
It's the same thing, almost setting up packet DNC then.
Yes, it's very, very similar. Yes,
You
sir.
know, does the analog reader run 6 1/4 bandwidth?
No, it doesn't. But what you're doing is, because in a 9600 baud packet arrangement, you basically have direct access into the modulator at even down to DC. So what you're doing is you're just kind of controlling the amplitude of the signal being applied to the modulator and just trying to control basically how much deviation you're getting out of it. Okay, so that's really the key thing, is now you've got radios that you can pick up and work with today. So you're seeing more people actually using some of these older 9600 baud enabled radios. Okay. Or what some people are doing is the same concept. They start tying this in here, do the same thing, and relaying information and reusing or refarming their existing analog repeaters. They're using the cavities, they're using the power amplifiers. You're transmitting GMSK, just like FM, it's all constant envelope. You don't need any fancy linear amplification. And just taking two existing radios that are, equivalently 9600 baud type radios or whatever, hooking them up through a modem. And just here they were just going out through a computer or a rack mount computer in this particular application here, and out and providing a gateway connection. Okay. So this is where people are starting to leverage some of the older technology as an interim step. And there's a lot of experimentation also going on in building homebrew repeaters, and there's a lot of work going on in an entire open gateway standard as well. So that's really where a lot of the experimentation is focused on. What I'm hoping to encourage more experimentation is in people actually trying to build more of the actual D-Star radios, okay, which I'm going to talk about or encourage a little bit later here. The other thing you can do is take two radios and do a crossband repeat, same thing. Okay, so now you don't have the duplexers involved, but you could do a crossband operation. So this would be something you would do, let's say, in an emergency scenario. Just go ahead and put one up at a high spot, drive up to somewhere and do a crossband repeat configuration. Okay. So the node adapter can run standalone radio to radio, or it can also run through a computer and actually go out through a gateway connection. Okay, earlier I mentioned these things they call reflectors. All right, and a reflector, like I said, is essentially it's a conference bridge. You've got a high bandwidth point, and your gateway connection is taking you to this one high bandwidth connection here. But there are D-Star reflectors out there that are intended for both local, regional, and worldwide connectivity. All right, today there are over 40 reflectors in existence, and they tend to grow. I think everybody is now turning it into their thing du jour, to set up their own reflectors here. But one of the neat things about it is, remember I said with D-Star, your audio is digitized at the source. It's digital at the source. Everybody's audio quality is consistent. So you can have worldwide conversations with people, and everybody is at the same audio quality. And I have driven around, I'll connect many times driving around, I connect to Reflector 1C. And it's actually quite interesting to actually participate in this one net. It used to be called the Ozark Mountain D-Star net. It was on Sunday evenings. They now changed it to, I think, the Worldwide D-Star net. And you would have people checking in literally from all over the world. I mean, Japan, Australia, England, other parts of Europe, United States. Here, everybody is able to talk just like it's one mega repeater. But the advantage of that digital audio is that everybody is understandable. There isn't the noise and fading and things like that that you would have if it was a standard analog radio connection or a shortwave connection. Yes?
What about time delays? Is there any problem with latency? You have all these networks and the problem with voice is it has to be essentially real time. How well does that work?
Well, it does. The bandwidth that you're using in D-Star isn't all that great to start with. So there isn't a huge choking of the pipes, if you will, to start with there. But again, you're still doing things like you would in a standard radio. It's push to talk, one person's talking at a time. So it isn't like your traditional telecom type full duplex thing with multiple people simultaneously talking and simultaneously listening. And everybody's going one at a time. Okay, so that's probably the one distinction that you would have as opposed to like a full duplex type arrangement there. But really, the lag is not really the issue. More than anything, it's just getting people to get into the network, fully if they're coming in through a repeater to make sure they're not sitting at a fringe or whatever. But after that, I mean, it'll work very well. So there's really no issues there on any delays or lags or whatever. Probably the only thing that you would have problems with is trying to come in through like an extremely low bandwidth, network connection or something like that. Dial-up is not going to handle D-Star, okay? But an ISDN line and up would be able to handle D-Star.
What about like those satellite internet links for people way out in the boonies? With all the huge latency and bouncing of the units and this order back, would that be too much latency in the link?
No. Because again, you're only transmitting one way at a time. So the latency is just going to be something where you just added another quarter-second delay before the person has released their push the talk button. You hear a beep. Now you know it's your turn to talk. Yes, sir.
Yeah, the latency in those is hideous for certain applications and just unusable. But for general internet stuff, for general voice stuff, you can usually make those things work. Don't ever try to run a VPN through one, though. That's a disaster.
Yeah. And one thing, I mean, we're not doing any elaborate security measures where you got to worry about packets timing out or anything like that. But again, with these reflectors, you can come in through any method. You can come in through a radio. You can come in through, a radio hitting a repeater. You can come in through a DV dongle. You can come in through a radio, come in through a hotspot. Okay, there are multiple ways in to the D-Star network, and there's just the capability of linking everybody together through a reflector. So, kind of visually, it's like I said, you just come in through your radio network, or your other means here. Everybody's tied together, and everybody comes back down again through their particular D-Star connection. Okay, since we're all focused on technology, D-Star is really spurring people to do some experimentation and actually start doing development, which is actually a good thing. In fact, earlier we just had a discussion here about the TNCX modem here. So here's an example. Somebody built this thing they called the Muse Smart Digi, which is just a digipeater board that they put in here. But basically what they did is they added like essentially a small D-Star gateway. So they're actually linking together D-Star. So they're doing the APRS, and DPRS is basically D-Star's formatted version of your position data, like APRS. Brings these two together. So somebody built a little daughter board here that they're putting inside of the TNCX. Okay. This was an early experiment in actually trying to build a very low-end D-Star transceiver. And what they did is they took an Analog Devices ADF7021 chip, which can do GMSK modulation and demodulation, and they added an AMB vocoder chip onto the thing and did some experiments. Okay, so it only put out 20 milliwatts because that's all this little transceiver chip did. But this was one of the early experiments here. What they ended up doing later was Rob and AA4RC and Internet Labs, what they did is they got rid of this and they just used this radio as the guts of that little red box, that DV hotspot, okay, or that access point. That's all it is just this chip in here. Go back one slide? Okay. So this is an area, like I said, where people are just starting to experiment with the radio side. A lot of people have been writing software for things related to D-Star. One of the nice programs that's out there is called D-Rats, and you call it D-Rats because it's S-T-A-R backwards, okay? And he's written a very nice application here. Runs on a PC, lets you do things, drag and drop files, ties in with mapping networks, looks at your position report, shows an indication of where you're reporting, and now you can tie in D-Star and the GPS position data that you're sending and tie it into the APRS network as well. So the two are brought together. If you go to aprs.is, I think it is, I think is the name of the site, you can actually see things where the D-Star reports are coming out, and they're formatted basically in the APRS format. So you're bringing in position information, map display. He also has some very nice templates for forms if you're doing emergency comms. I'll show you a form in a second here. And he's also started providing some links over into WinLink 2000 as well. So these are nice free utilities. Just go ahead and download it and away you go. He actually built these nice forms, okay, sort of pre-formatted, ready to be populated with your information, and you can now send this out. So this is an example of where you would be doing your voice communications and simultaneously sending out the raw text that is used to populate these forms, and you're sending it to the other user. So just think of that from an emergency comms perspective, okay? There's another program called D-Star Chat, which is basically just a very simple keyboard-to-keyboard chat program, just little windows basically. You just hook it up to your D-Star radio, go into the data port connection that's in your radio there, which just goes to an RS-232 port. You just start typing and away you go. There's also another program, D-Starlet, which was intended for basically being able to format data and have computers that are connected together in a network setting, and basically formatting the data so you can now go out over a D-Star network. But the idea here in D-Starlet was to basically support this client-server configuration, allow you to share forms and other data, you know, more readily or whatever, and then have things formatted for transmission out over a D-Star network. Just like we have slow scan TV. I think you saw yesterday Bob Brunig was showing his little demo where he had a video camera and was just sending out stuff. So here somebody wrote a little thing they called D-Star TV. They're just doing the slow scan TV equivalent and just pumping it out over the D-Star radio link there. The thing that's neat is you can do low resolution images at low speed, or you can actually bump it up and run this thing all the way up at the 128 kilobits per second. So now you can actually start having like frame capture. Okay. And cross your fingers, hopefully in early 2012, this group in Belgium is going to launch a satellite, and its voice communications and control protocol is going to be based on D-Star. This has been delayed for a couple of years now, but they are actually focused on this. The biggest problem I've had, unfortunately, with this site is that everything tends to be only documented in a foreign language, okay? And yeah, so I have been left out. I know there was a YouTube link, and I thought, that's great, I'll see what they've done or whatever. And somebody's speaking in French at this conference, and I'm like, that was fun. Okay. So let's just take a quick shot here, comparisons of the technologies, okay? Like I said, if you wanted to compare D-Star to other things. So like I said, D-Star is about, you know, occupies 6.25 kilohertz bandwidth versus 15 kilohertz for traditional analog FM. Provides 1,200 bits per second of data simultaneous with the voice, okay? supports error correction in the voice stream here. Okay, so you're doing this, and also D-Star radios will default back to analog FM as well. Okay, so you aren't giving up something. Okay, as opposed to if you had a traditional FM radio, at the lowest end, the most you're going to do is get a 1200 baud packet and plug it into the microphone. Okay, that's your basic entry, if you will, into doing data over an existing radio. If you had a 9600 baud enabled radio, that's fine, then you plug it in that port. I'm going to play an audio sample here to give you an idea of how much the forward error correction is actually helping, okay, compared to analog FM. So I'm going to bomb out of this here for a second. Bring up this audio sample. And I'm going to just keep the mic close to my computer here so you can listen to this. And let me, hang on. Anything else you want to tell me? Are you dead yet? I know it. I'm going to fix this. I know, yeah. Resistance is futile. Okay, let's try this audio sample. Okay.
Okay, I found a place to turn around. This is KC5ZRQ on digital. Can you hear me? Okay, I'm going to switch to FM. So let's go ahead and switch to FM. This is KC5ZRQ on digital audio. We're going to change over to FM. And this is KC5ZRQ on FM. Test 1, 2, 3, 4, 5. I can hear you. Can you hear me? Roger, Roger. Can you hear? Okay, what did that sound like when I was on FM? Could you hear me okay?
Okay. So that's an example of where forward error correction, digital signal, or that a digital processing that's going on here is giving you that advantage, okay? Yes, sir?
That's what you're running for FM and D-Star when you did that?
That was, a guy had a D-Star radio, and he was switching between D-Star mode, digital voice, and FM mode. So he just stopped. He said, okay, I'm going to go to FM, have a conversation. You hear the frying pan noise, the hiss or whatever. Switches over, does his digital voice through D-Star. You hear the clarity of the audio, okay? That's the difference. But he was just the same guy with the same radio at the same location, switching modes.
Same frequency and all.
Same frequency, yeah, everything's the same.
So that brings up a question. With 6 1/4 kilohertz bandwidth, do you get greater range for the same power compared to regular analog?
You know, I'm going to be honest with you. With D-Star, the range is about the same. You know, when all is told. The other thing is he pulled off somewhere and was stationary. It's another thing when you start going mobile. And this is where D-Star uses an interleaver to handle some of the fades that occur, you know, picket fencing and things like that. So really trying to have an apples to apples comparison or whatever, I think you're going to find that D-Star is going to perform about as well as analog FM. But that was just an example of the enhancement that the digital audio side of D-Star brings to communications here. Okay. Like I said, if you compared it to things like Echolink and IRLP, if you come in through an Echolink-enabled analog repeater, the quality of your audio coming into that repeater can vary quite a bit. You could be having that noise as you're starting to get to the fringe areas, okay? So your audio quality can vary greatly. Now, if you're sitting at home, you've got a headset, you're at your computer, you're going in through Echolink, all right, you're at the same quality level as D-Star, okay? So like I said, the one advantage is once you're in D-Star, once you're in the network and you're solidly in, your audio quality is consistent, all right? You know, and basically these things were inherently computer-based applications. They are things that are running on top of a computer, but D-Star is that all that digital capability is built into the radio itself. That's one of the other distinctions. Okay, with APRS, in general, you're going to need an external TNC. With D-Star, you're just going to need, depending on the radio, okay, like the one I have in my car, the GPS is built into it. With the other higher-end D-Star radios, you can get GPS built into them as well. They have their own format that they use for GPS. There are conversions. It's very standard for going into the APRS world, but just trying to highlight that. A number of people said, well, how come we just didn't do what they do in the public service community and go to APCO 25 and follow them and whatever? Okay. Well, actually, there's actually a lot of similarity between the two. We're using the AMBE chip, it's advanced multiband excitation, whatever thing. Okay. They're using the IMBE vocoder, same company, it's just a sister arrangement here. AMBE is actually used in a lot of the satellite phones and other things. It was just the most reasonable technology that could be ported to a chip that could be easily installed, in a manufactured item. The public service community, the P25 community, they're using sort of an architecture very similar, on the underlying structure to what we do. But the main thing is if you really try to fully encompass and incorporate a P25 networked architecture, if you actually look at how they do it, it's a highly structured architecture. It's really more of this tree structure. They don't want a fireman at some locality who can just automatically dial up somebody in the state capitol or whatever and complain to the governor about something. Okay. You have to be given permission to keep going up the chain, if you will. All right. As opposed to D-Star, it's a flat architecture. You can talk to anybody. Everybody's a peer, all right, which is the way we hams communicate. So I'm just saying there's a lot of technical similarities on the radio end, if you will, but from the network architecture, it's different. So I think we've only really begun to scratch the surface here of what we can do with D-Star digital technology. So I encourage you as the technical folk within ham radio to really embrace these challenges and actually try and do some more things. Yes, sir.
Right now, ICOM is the only commercial manufacturer that's into D-Star.
Yes.
Well, Kenwood, Elenco, Yaesu, where is everybody else?
Amen. I agree. I really think it's up to the hams and the ham community to really start beating the drum and tell them, I'm not a great fan of ICOM or of D-Star, the ICOM product. I'm much more interested in D-Star, the radio technology. And I would really encourage other manufacturers. This is why I'm trying to ask people or suggest this would be a good community if people started off and if a manufacturer started building just a D-Star module. All right, so take away the front panel display, the push button, the case, whatever, and just give people a brick that they can start experimenting with. Or there was some work done initially and it kind of tapered off in just building a digital voice adapter to plug into the existing 900 or 9600 baud enabled radios. The problem is it's apparently, they view it as a zero-sum game. If they do something, it's helping ICOM, okay? And I really think it's up to the amateurs to really start saying, get on the bandwagon, we're interested in digital technology, and leave your corporate food fight, for whatever. So, I agree. We definitely need additional manufacturers to get into the game here. Fully agree with you. Yes, sir.
Looking around in Scandinavia, especially in Sweden, where I'm coming from, somewhere in the mid-'80s we had a lot of surplus when it came to old cell phone stuff. Mm-hmm. The systems were prior to the automatic analog. Uh-huh. And I guess it's not that hard if people know what they're doing to rebuild those radios to become digital. Mm-hmm. Okay, you have to throw out bits and pieces here and there, but if you know what to do, it seems to be, well, I think it's likely to do this. What is the situation when it comes to that kind of equipment here in the U.S.?
You know,
I'm not going over, maybe you don't want to go inside an older commercial ham radio and start to fiddle around with electronics.
yeah, I mean, it would be a great starting point. I just haven't seen people do that. And I think in this technical community here, you're going to see a lot of people that want to build things from the ground up. You know what I mean? They want to start doing some experimenting. The 9600 baud packet port just happens to be something that people can rapidly use as an interface point to do some experimenting. I would definitely like to see more of it. You know, for whatever reason, I'm just seeing a lot of people in the amateur community just tend to be kind of stuck with the complacency of the existing analog FM stuff. And you know, I really make the argument too, you know, and this kind of ties in with the other things about, you know, amateur radio, emergency communications and all that. One of the other comparisons I would probably want to put in here is, why is ham radio or why is D-Star any different than just getting an FRS or GMRS radio? Okay. Anybody today can walk into a Kmart and buy a cheap radio and push to talk and release to listen, okay? It's just another FM radio, just like our existing ham equipment here. If it isn't our training or if it isn't some other technical capability that we really bring to bear here, we have to, as the amateur community, have really got to ask ourselves, you know, why isn't somebody's going to start asking the question, well, why are they relevant? All right. It's really up to us to really take on a challenge and start doing some of these new things. So you know, in general, I agree. We need to really start kind of pushing back and hammering on these manufacturers, you know, that they really need to start listening to us a little more. And I know that's been a difficulty and a complaint that a lot of the traditional Japanese manufacturers are very one-sided in their view, you know, that they are the determiners. But this is why I really think we could probably start looking at others and encouraging them to help. And that's why I would want to start with just a module as opposed to a finished product like a handheld. Yes, sir?
Just to follow on to the same question, it seems to me like they're building these radios for the Japanese home market and not so much for the North American market or the European market. I lived in Japan for a while, and I remember the radio there was, the use cases were very different than they were here. There's a lot more mobile operation. There's not so many people that have their own home station there. And I wonder if that might not be part of what we're seeing here. Why it hasn't been taken up so much.
I don't know. I think there's just been an entrenched infrastructure here, you know, and people are complacent.
I agree with you that the demand will create the supply.
Yeah.
But it kind of makes me think that they're not building this stuff for outside Japan.
I understand ICOM was actually trying to take this technology and market it as a, you know, like in the public service radio field as well. They're trying to kind of play both ends, if you will.
Competitor P25.
Yeah, yeah. But like I said, I really think they started something, it's interesting, but I really see it as this community is the right one to start embracing and making changes. You're seeing a lot of work going on in people building enhancements and changes to like the gateway software, the architecture using now. They want to do, it's called IRC DDB, where they're using the internet relay chat for routing. Okay, so there's a lot of work going on there. A lot of other open D-Star stuff or whatever, but the one area that people really haven't addressed, and you know, for people talking about all the software-defined radios and other things like that, I haven't seen anybody yet really address the whole thing of building a radio. Okay.
Yeah, I mean, I live in a very rural environment. You know, I'm 45 minutes from the nearest interstate, the direction you want to head. I'm only 100 miles away from here. Okay, but you know, the local club has 25, 30 members in it. They've had a beer cup for 20 years, and you know, the median 55 mean age is a bit over 9. So you know, for me to go out and invest test the D-Star radio. I don't know if D-Star trickles down that far out as a DC area or not. But if it doesn't, that means I've got to build a repeater first.
Well, or like you said, you know, the hotspot that I was describing, I used a radio, I set it up at my house. All right, that's what I use as my entry point. I actually did that because one of the repeaters I used to get into in my area, they had a failure in their gateway connection, and the guy who was responsible for it, you know, was laid up injured. He hasn't been able to get back up to the site to fix the gateway connection, yada, yada. I was having D-Star withdrawal, okay? So I just went ahead and bought an old radio, put up a hotspot, and that's what I use now for getting into the D-Star network. It's a way of doing business that you can get a radio, run around locally, do your thing, or get a DV dongle or whatever. You're always going to have those tensions, okay?
No, I was kind of interpreting what you're doing with the hotspot that way.
Yeah.
You could put it
Yeah.
on.
Yeah. Okay.
That's what I was going to say, kind of something up in Green Bay before we got our repeater. We were running the Shitoshi board for quite a few years before we got our repeater up there.
Yeah.
And it's a cheap, easy way to set up. But we just took an existing analog repeater and interfaced the Shitoshi board, and we had a D-Star repeater. He had it up in that picture.
Yeah.
It's a node adapter board.
Yeah.
Where do you get that?
You can, if you just literally go on the internet, just type in Satoshi, S-A-T-O-S-H-I, D-Star. He has the link. I forget, it's a long link. I believe it's in the slides here as well. I could probably pull up the address, you know. But there's that. The board I have, it's actually called the Not Quite So Mini Hotspot, okay, was the actual name of the board. And there's a new one that's coming out. There's another group called, in the Netherlands, they're called Dutch Star. If you just type like D-Star in Netherlands, you'll find a site there. And they're selling a lot of stuff. And they're actually seem to be making some progress and actually building some more unique, you know, D-Star type products or whatever. I'm noticing a lot of growth in D-Star in the European side for whatever reason. But I think here we've just become very complacent, and I think we're very used to just running to the store and buying a radio and off we go. And it's really going to take a drumbeat for the amateur community to say, we want digital technology, okay? Not necessarily an ICOM product, we want digital technology. Okay, any other questions at this point? Yes, sir.
Looked at the EMR. They have a letter by Motorola. I guess it's a European standard.
Oh, yeah. I've heard of it was the Moto Turbo, Motorola's thing called Moto Turbo, I believe.
Yeah, they call it Moto Turbo, but I think it's an implementation of basically a European standard called digital mobile radio.
Yeah. There is, yeah, there are a few aficionados that are going out and doing this, but you know, it's again a niche, and I think, unfortunately, you see a lot of times where people just find the newest shiny thing and they run in and they grab that or whatever and start playing with it. But if anything, there are about 20,000 users out there in the U.S. here, or I'm sorry, I'm trying to think how many worldwide, but I think there's like 18 to 20,000 users in the U.S. That are on D-Star. So it started. Is it perfect? No. Okay, but you know, do you want to add another standard to an emerging standard? You know, it's one of those things. Which one's going to win out? I don't know. But there are people starting to experiment. I think there is at least one Moto Turbo repeater, I think, now set up in the Washington, D.C. area. Okay. All right, I believe I am way out of time. Any other quick questions? And if not, we'll just wrap it up here. Okay. All right, well, thank you very much.